In this problem, we're going to look at how to take the derivative of an implicit relation that includes the product rule, and also how to find the value of the derivative at a given point. So remember, with implicit differentiation, we are able to take the derivative of each term as it comes, which is a benefit. There's no rearrangement necessary. What is different about implicit differentiation is anytime we have a y, like we do here and here, we have to assume that it is some other function that we don't yet know. And so we have to apply the chain rule to it by multiplying by the derivative of the inside, or y prime. In the last video, instead of y prime, you saw dy over dx. That is one way to do the notation. In this example, I'm going to show it using just the y prime. So taking the derivative of each term, the derivative of x cubed is simply 3x squared. It's a basic power rule that we've worked with over and over again. Now, in the second part here, what you should notice is we have a product rule. And we know it's a product rule because we have 3x, which is a function in itself, times y squared, which is some function that we don't yet know. So I'm going to need to use the product rule. I'll have u be 3x, which means u prime would be 3. And then v would be y squared, the derivative of which, the beginning you know very well, would be 2y. And then we multiply times y prime because, again, we're saying that this is some function that we don't yet know. And so if there's an inside, we need to multiply by the derivative of the inside, which would be y prime. Okay. So now putting those back together, I've got vu prime, so plus 3y squared, plus multiplying u times v prime, we would get 6xy y prime. And I want you to notice the order that I put this in. I go in alphabetical order. That helps me keep track of things. And I always put my y prime last because we will need to isolate that eventually. The derivative of 5x is minus 5. And that's equal to the derivative of 4y. The derivative of 4y would be 4. And then we need to multiply by the derivative of the inside, whatever that y function is. So we call that y prime. Now, once we have it here, our goal is to get everything with a y prime on one side, everything without on the other. So I notice that this does not have a y prime, this does not, and this does not. Whereas this term and this term both have a y prime. So if I'm going to make the least amount of work possible for myself, I'm going to move all my y primes to the right side. So I'll subtract 6y y prime, 6xy y prime from both sides. Now, when I do that, I end up with 3x squared plus 3y squared minus 5 is equal to 4y prime minus 6xy y prime. Now, my reason for doing this is I need to isolate my y primes. And I'm going to be able to do that now because both of these terms have a y prime. So I'm able to factor y prime out front, and I'll be left with 4 minus 6xy. And then over here, everything will stay exactly the same. My final step is to get y prime by itself because I want to know what the derivative is, and y prime is the derivative. So I can do that by dividing both sides by 4 minus 6xy, which gives me my final answer, which I will write in red. Y prime is equal to 3x squared plus 3y squared minus 5 divided by 4 minus 6xy. Now, in this particular problem, we are being asked to find the derivative at a particular point. If we were just being asked to find the derivative, we would be done at the step that we just did right here. But to finish this problem, what we're going to do is take the point we were given and input that into our derivative to find our final value. So here I have the basic layout of the problem, and now I'm going to put the values in where they belong. So wherever there was an x, I will put a 1 in its place. And wherever there is a y, I will put a 2 in its place. And then I'm going to use my order of operations to simplify. So utilizing my order of operations, I will square both 1 and 2 before I end up multiplying by 3 in both cases. So I end up with 3 times 1, which is 3, plus 3 times 4, which is 12, minus 5 in the numerator. And in the denominator, I have 4 minus 6 times 1 times 2, which is 12. So in the numerator, I end up with 15 minus 5, which is 10. And in the denominator, 4 minus 12, which is negative 8. And I can simplify that to negative 5/4. And remember what that means. The derivative is the slope of the tangent line at that point. So this relation that we started with, x cubed plus 3x y squared minus 5x equals 5y, it has a tangent line at the point 1, 2 with a slope of negative 5/4.